This is the Pythagorean theorem worksheet, and y'all are to please work the odd problems, so I'm going to do a few of the even problems for you. So Pythagorean theorem says a squared plus b squared is equal to c squared. And that describes the relationship between the lengths of the sides of a right triangle. A and B are the legs, and those are interchangeable. It doesn't matter which is A or which is B, but C is the side across from the right angle. So in number 2 here, we can see that this is C. So this is going to be 12 squared plus 35 squared is equal to x squared. You get 144 plus 35 squared is 1225 is equal to x squared. If you add those, you get 1369 is equal to x squared, and so x would be equal to the square root of 1369, which is 37. Okay, now here it says round your answers to the nearest tenth if necessary. So what that means is that if you do not get an integer, you can leave your answer as a decimal here. Okay, so let's look at one more of these. Let's look at number 4. Here, this is C. So a squared plus b squared is equal to c squared. This side has to be c. So this is x squared plus 9 squared is equal to 41 squared. You get x squared plus 81 is equal to 1681. If you subtract 81 from both sides, you get x squared is equal to 1600, and the square root of 1600 is 40. So x is 40. Another thing to keep in mind is that C is always the longest side of the triangle as well. So 41 is longer than 40, so we're good. Okay. Sorry. Let's move down to number 10. Okay, once you get here, it tells you that it wants you to leave your answers in simplest radical form. So that means we do not want a decimal. So if you look at number 10, here's C. So we have x squared plus the square root of 10 squared is equal to the square root of 17 squared. Now, if you can remember, anytime you square something, this would be like the square root of 10 times the square root of 10, which is the square root of 100, which equals 10. Anytime you're going to square a radical, you're going to get the radicand itself. So this is just going to be x squared plus 10 is equal to 17. You subtract 10 and you get x squared is equal to 7. And so x would be equal to the square root of 7. You can't simplify that anymore, and so that is your final answer. X is equal to the square root of 7. Okay, let's look at number 12. Okay, number 12. Here's C. So we have x squared plus 8 squared is equal to 18 squared. So we get x squared plus 64 is equal to 324. Okay, and so if I subtract 64 from 324, I get x squared is equal to 260. And so now x is equal to the square root of 260. We do need to see if we can simplify that. Okay, that's the answer, but we want to try and simplify that radical. So I am going to go over here and make a factor tree. 2 and 130, 2 and 65, and then 5 and 13, I believe. Yeah, okay. So there's my factor tree. So I have a pair of 2's, and then I have 5 times 13. So I can rewrite the square root of 260 as the square root of 4 times 13 times 5 is 65. So I can take the square root of 4, so that's going to come out of the radical, and the 65 stays under. So that is your final answer. 2 times the square root of 65. So be careful and see if you can simplify those if possible. Okay, let's scroll down now to one like this. Find the missing sides of each right triangle. Side C is the hypotenuse, A and B are the legs, and leave your answer on the simplest form. So this is the same kind of thing. Let's look at number 18. Okay, let me go back here. Okay, so we have A, B, and we're looking for C. So 13 squared plus the square root of 145 squared equals C squared. So this is 169 plus 145 equals C squared. 169 plus 145 is 314 equals C squared. So C is the square root of 314. And so you want to see if you can simplify that. And if I go to make a factor tree, I get 157 here. And I can tell you, I looked at 157 and tried, you know, I just took a calculator, tried to divide by 3, 4, and so on. And that is not, that's a prime number. So this is your final answer. It cannot be simplified. All right, and then the last one's on here. Oh no, there's 2 more types. We have this one where it says state if it's a right triangle. So all you have to do here is you just want to know, is this a right triangle? Well, if it's a right triangle, A squared plus B squared has to be equal to C squared. Okay, it looks like this would probably be the right angle down here, but we're not sure. But this is the longest side, so that has to be C. So you just put 8 squared plus 15 squared, and you want to know, is that equal to 19 squared? So we get 64 plus 225 is equal to 19 squared is 361. 64 plus 225 is 289. That is not equal to 361, so no, not a right triangle. And then the last examples on here, they give you the 3 sides and they ask you if it forms a right triangle. So again, you do need to check on one like this and make sure that this is the longest side to make sure that's C. But if you put the square root of 73 in your calculator, let me do that, I'll get an approximate answer for the square root of 73. I get 7.07, so yes, that is the biggest side. So now we want to know, is 7 squared plus 5 squared equal to the square root of 73 squared? 35 plus 25, is that equal to 73? Nope, it's not. So not a right triangle. Okay, hopefully, let's go ahead and look at one more like this. 32, because I see this here. So I want to make sure y'all know how to multiply that. Again, you can put that in your calculator and make sure it is the longest side. But 5 times the square root of 5 is 11.18. So yes, it is. So we want to know, is 5 squared plus 10 squared equal to 5 to the square root of 5 squared? So this is 25 plus 10. Now what happens when we multiply 5 to the square root of 5 times 5 to the square root of 5? You multiply this 5 times this 5 and you get 25. And the square root of 5 times the square root of 5 is 5. So 25 times 5 is 125. So yes, this was supposed to be 100, sorry. So yes, those are equal. So yes, that is a right triangle. Okay, good luck.